Haha, psych. I thought there was 15, but apparently 16. All right, so this is the last one. End behavior. All right, so we got x squared times an x times an x. So this will be an x to the fourth. And remember, x to the fourth acts like x squared, the parabola, except it's a little bit more vertical at the ends, in the middle. X and y intercepts. Let me get this out of the way. Flippity, flippity, flip. All right, so we have f of x equals x squared times x minus 2 times x plus 2, and x-intercepts. So we're going to set the function in its factored form equal to 0, set each of the factors equal to 0, and solve them. So this will give x equals 0, and that has a multiplicity of 2. Which means when we graph this thing, the graph will only touch at the x-axis at 0. X minus 2 equals 0, that will produce a 0 of 2. That has a multiplicity of 1, because it only showed up in here once. And it will cross the x-axis at x equals 2. And x equals negative 2 will be the last 0. It has a multiplicity of 1 as well, so the graph will cross the x-axis at negative 2. Y-intercept. Plugging and chugging 0 into the function. So f of 0 equals 0 squared, 0 minus 2, 0 plus 2. So 0 times negative 2 times 2 is 0, which I said earlier, if 0, 0 ends up being one of your x-intercepts, then you know 0, 0 is one of your is your y-intercept. So let's fill this in. X-intercepts are 0 to negative 2. Y-intercept is at 0. The zeros, same as the x-intercepts. The smallest 0. Okay, so we gotta pay attention to which one's which. We got negative 2, 0, and 2. So the smallest one is negative 2. It had a multiplicity of 1. And the graph will cross at x equals negative 2. The middle 0 is 0, which had a multiplicity of 2 and will touch. So the middle 0 is multiplicity of 2. Graph will touch at x equals 0. And the largest was multiplicity 1. Right? The 2 had a multiplicity of 1. And it will cross the x-axis at x equals 2. All right, let's see. Make an approximate, sketchy sort of picture. Now, somewhere in the background over here, you might have heard some pitter-pattering and seen some shadowy stuff. My son James, the one that kept me home today, is wandering through the kitchen. He'll stick his face underneath here and he can say hi. Hi, yeah. So we're almost done. And then James can have some lunch. All right, we have 0, negative 2, and 2, right? We decided that this was going to have arms that go up. Oh, no, I think my pen just died. Oh, James, I need your help. Look in that bin and see if there's a new pen. Stay tuned.
One works out.
Yeah, this will work. All right, this is a really skinny one, but it'll get us through. All right, so we got that. Now we're supposed to grab these two at negative 2 and positive 2 and cross through, but then we're supposed to grab this one and just touch it in the middle. So something like this is going to happen. Oh, can you see that? Can you get me another? Yeah, give me another pen.
This one's good.
Yeah. So a little easier to see. All right. So, and I'm not sure how far down these things go. You know, that you would have to determine that with your grapher. But that should give us enough to figure out that it looks like this. The turning points, let's see, looks like we're going to have one between -2 and 0, and one between 0 and 2. So I'm going to go with these two, because it's definitely not anything that ends with a 0, because those would be the intercepts, right? And then the graph that looks like we had before. All right, so now domain, it's still a polynomial function. The domain is still all reals, -infinity to infinity. But this one does not have a range that's all reals. I'm going to include in my graph over here my turning points. All right, so the smallest value of y that's coming out of this function is going to be down here at these turning points, and it looks like it's going to happen at -4. So -4 to infinity. Actually, this is going to be a bracket. Look at it. It's still taping. Just making sure. James is concerned because the 20% message came up on my phone. All right, bracket. Don't forget a bracket there. All right, use the graph to determine where the function is increasing. All right, so here we're decreasing till we get to the turning point. So -infinity, it's -1.41 is decreasing. Then we increase a little bit right here. So, and that's at 0, right? So -1.41 to 0 is going to be an increasing, and then we decrease a little bit here. So that's from 0 to 1.41, decrease, and then we will increase up here. So that'll be from 1.41 to infinity. All right, let's fill these in. Increasing. So we have -4, 1.41 to 0, and 1.41 to infinity. And the decreasing is -infinity to -1.41 and 0 to 1.41. And that, my friends, is that.